Well, welcome everyone. This is our weekly code talk done on Mondays and taught by Ben Turner. vSchool is sponsoring this. It looks like there's some good chatter happening in the chat, so that's fun. Feel free to reach out, make connections during this event. It's one of the most important things you can do is networking. But we're really grateful for Ben for holding these events and for vSchool for putting them on. vSchool is a coding bootcamp that teaches both full stack web development and user interface design. So if any of you are interested in learning more about that, or if you have referrals for me, I'd love to help you out. I'll be dropping my cell phone number in the chat. You can call or text me anytime. For those who are interested in referring someone to me, if the person you refer starts school with us, there's a $500 referral bonus. So keep that in mind as you go through this code talk and as you think of people who might be interested in changing careers, upskilling, or just learning more about the tech industry. So I will turn the time over to Ben now, who is actually a graduate of vSchool and a former teacher. And it looks like Lainey is connecting with us as well. Lainey is our outcomes director, and she is in charge of getting all of our students into their career. She does an amazing job. So connect with her on LinkedIn. And if you need anything, I'll be dropping my number in that chat.
Sweet. Thank you, Debbie. Sweet. So welcome everyone. The last few weeks I did a TypeScript series, but that is over. It was like kind of a marathon of information. Today we get to jump into a new topic, which I'm really excited about because it's one of my favorite things, I guess, in coding, promises. So the reason why I chose promises is because I think it is one of those topics that is kind of a rite of passage for junior developers. So without having more than without having a comfort level with promises, you're going to really struggle to find employment as a developer because they are ubiquitous. They're everywhere. We're dealing with them all the time. And being comfortable with dealing with asynchronous code and promises, at least in the JavaScript realm, is pretty critical. So I'm here to try to maybe fill some gaps in all y'all's knowledge. I don't know everything about promises, but I feel like I know a lot. So today what we're going to do is I'm going to give a quick overview of what a promise is and kind of how asynchronous code works in the browser, just kind of generally speaking. And then we'll talk about how promises are implemented. We'll use the Promise Constructor to kind of really get an understanding of what's happening when you're using promises. And then we'll talk a little bit about Async Await and just some good patterns and stuff to keep in mind with promises. So, does anybody have any questions just to before we go into it? Feel free to either go in the chat or yell out loud. Cool. All right, let's do this thing. I'm gonna share my screen. Oh crap, I closed my. All right, here we go. Okay, I've got some crap here I don't really need. Alrighty. Okay, so top level stuff. So with to really appreciate promises, it's helpful to actually put it into the context of how JavaScript actually runs and how it executes. So people get really confused, or I think people tend to conflate asynchronous code with concurrency, or things running in tandem. So JavaScript is a single-threaded language, which just means that there is only one execution thread running at any given time. So there are things called web workers, which are kind of a separate JavaScript thread, but we won't really get into that. But when you're running a JavaScript program, it is running on a single thread. There's no other jobs happening in regards to that. So asynchronous is not the same as concurrency. That's kind of the first lesson. Concurrency means you have separate threads or separate processes happening simultaneously. Asynchronous is just referring to the order in which code is executed. So synchronous code obviously is just executed as you expect, just top to bottom, left to right. No mystery there. But it's not necessarily concurrent. Although anything that is concurrent, you could probably argue is asynchronous, but it's not the other way around. So with that in mind, it kind of begs the question, well, if JavaScript is single-threaded, then how is it that it can manage asynchronous code? And that is it seems like a paradox. However, this is where we introduce the concept of what's called an event loop. And there are tons of resources on this online. But what I'm going to do, use this little Sketchpad program that I like to try to diagram what I mean. Oh, this is from a past situation. I don't use this thing very often. How do I want to just erase this? Everything. Can't I just like
maybe select all delete?
That sounds like a great idea. Wow, genius. Thank you for reminding me of that exists still. All right. Okay, where am I? Okay, so the event loop, just try to diagram this out a little bit. I don't want the calligraphy, I just want a pen. Okay, here we go. Beautiful. Okay, so now it's a little hard to diagram this because it's very abstract, but there's a couple processes that a browser is actually kind of running at the same time, and Node is kind of similar. So we're going to use this to represent the main thread. So this is just like your code. Let's say it's like, you know, your app.js file. Okay. So your code is just written like this, and it executes line by line. Okay, cool. Just in that direction, just like that. Easy. Okay. However, as this is being executed, which of course is done by the JavaScript engine, as it's running this thing, there is actually a separate process, or maybe I should call it a structure, called the event loop, running. Okay, and the event loop is essentially responsible for managing asynchronous activities. Okay, and the way it works is there's basically this holding area, and I'm intentionally being a little vague. I don't want you guys to get too lost in the details here, but there's basically this holding area, which you can kind of just think of as a queue or like an array where things enter into the back and go out the front. So it's a queue. This is how queues work, where it's first in, first out. So what happens is anytime during the main thread, the engine encounters a promise or any sort of asynchronous code. So a promise is not necessarily the only way that asynchronous things can happen. It's just one of the main ways. So anytime it encounters something, it essentially, I'm oversimplifying this, but essentially that thing, when it finds it, it gets added to the queue. Okay. And it's a block of code. It's a function or a block of code that gets added to this queue. Okay, so then you get this, over time, this just gets filled with people waiting, or code waiting in line, kind of like people waiting to vote. So at the end, once the main thread finishes executing, then what it does is it pops off the first thing in this list and starts executing it. And once that's done, it goes to the next one and the next one, and it will just continue until this thing's empty. So that's kind of how you can still maintain this single threadedness while still having it be asynchronous. So you guys probably know this. What is one of the most common implementations of asynchronous code? Or what's the most common way that we use promises?
Fetch call.
Yeah, fetch calls. Anytime we make HTTP requests to like an API or something. There are actually others that don't have to do with servers. Anyone want to take a guess as to another thing that is asynchronous?
Set timeout.
Yeah, set timeout and set interval. Those are the two kind of main ones. So set timeout and set interval, which I'm sure some of you have encountered. So if I were to say, do this thing after so this set timeout function, let's say I wait for 3,000 milliseconds and I say, when you look at this, it seems like, the code's written, again, top down, left to right. And visually, this appears first for this line. But because due to the asynchronous nature of this set timeout call, what really happens is when the code executes, the engine sees this and goes, oh, let's tell the event loop about this, and this guy will get added to the event loop after 3,000 milliseconds have passed by. So what ends up happening as I run this, it's just that. So as I run this, I don't know why this is called this. I need to rename that. I'm just going to call it main. Boom. So despite the fact that this was written first, this executed first, followed by this 3 seconds later.
You said that will be added to the queue.
Yes, this callback function
Will be added to the queue or will be called to the queue after
it will be added to the queue after 3,000 milliseconds.
Wouldn't be the added first and then after 3 seconds call it from the queue?
That's a good question. No, this is why set timeout and set interval aren't always perfectly reliable, because if you have other stuff in front of the line, those are going to get executed first before this guy does. If after that time, there's stuff there, like if there's still items in the queue, then this is still going to have to wait its turn. This simply means add to the queue after 3,000 milliseconds. That's a subtlety that gets overlooked. So that's a good question. In most cases, it's a matter of like milliseconds, and it probably doesn't change much, but it is good to understand that that does not mean execute this after 3,000 seconds or 3,000 milliseconds. It actually means put this into the event queue after 3,000 milliseconds.
So if it's added to the queue after 3 seconds, then that means that there is some type of another queue to prioritize what is called first and second.
Yes, but it's just a queue. So it's just doing one thing at a time. Whatever got there first gets executed first.
Okay.
And there's a separate like process that handles that. I honestly don't know really how it works, but it's written in C probably, or C++ maybe. I have no idea. Cool. So this brings us to we're going to kind of look at a short history of asynchronous code. This callback pattern, before like promises were part of the spec, this was kind of the way that you did stuff. You passed in callback functions, and that introduced this notion of callback hell, right? Where you have this thing called, let's say I have a function called do thing, and then I say, here's the function that I want to happen after the thing is done. So thing is done. Oops. And then it's like, okay, well, after the thing is done, I want to do another thing. But that also takes some time. So we're going to another thing done. And this right here is called callback hell, because this becomes pretty difficult to manage. Have any of you spent any time in callback hell? It's not very fun. So one way that, so instead of dealing with this way, what promises kind of allow you to do is essentially manage asynchronous code in a seemingly synchronous way. It's just a way of managing these things. Even though under the hood, they're still getting called out of order. A promise lets us like manage that a little better. So does anybody have any questions up to this point before we do an example? All right. So I think the most confusing part about learning promises at first is that they're not this scary magical thing. They're literally just an object. Okay, so a promise is just an object. I want you guys to remember that. It's just an object. It's a very fancy object in the sense that it has like a lot of cool properties, but it's just an object. And once you realize that, you will, I think, find them much easier to deal with. So a promise is just an object, and it is an object that can be in one of three states. It can be pending, resolved, or rejected. Oops. Okay, that just means that it has a property that's one of those things and only one of those things. And once it has been resolved or rejected, it cannot be changed to any other state. Make sense? So promises also have this really cool property called then. And it's called then specifically because they call it that so that we can think of it in terms of time. It has this like temporal feeling to it because asynchronous code is so hard to manage. Naming the method then lets us, like, in our human brains think like, oh, do this thing and then do this other thing and then do this other thing. Okay, so a promise is just an object that has one of three states and it has a method called then. It has some other properties too, but we're not going to worry about them. So that's it. That's all you have to remember. A promise is just a property is in one of those three states and has a property called then, or a method called then. Okay, so the question then, no pun intended, is how does this work? So what we're going to do is we're going to look at the promise constructor to see kind of how these things kind of work together. Okay, so we're going to make a promise called flip coin. Okay, so what this is going to do is it's going to be a promise that's going to give us heads or tails after like 1 second, because you can imagine, like, flipping a coin and it's kind of suspended in the air for a few seconds before you know the answer, or before you know it's heads or tails. Okay, so flip coin is going to be a promise. Oops. Okay, cool. Now for this to work, so remember, so now I've got this object, or I've got this promise called flip coin. So now I can do stuff like say .then, and we'll talk about catch. I won't talk about finally. It's rarely used. The idea though is that I want to be like, okay, I flip the coin and then do something with the result. Okay, so it uses this callback. It uses this callback pattern, just like set timeout. So however, the question then is, where does this come from? This value. I want to be able to ask this promise what its result is. But where does this come from? Anyone want to take a gander?
The response, or if it when it's resolved or
Yes.
rejected.
This is the resolved value. So like we said, a promise is an object that has a state, an internal state that's either pending, resolved, or rejected. So when we call .then, what we have to do then is provide it a callback that takes the resolved value as an argument. So in this case, we have to decide, because we're creating a promise, we have to decide what is going to be that resolved value. So when you're creating a promise, you actually have to tell the promise something. You have to give it something to work with, and it happens to be a callback. So this is where things kind of get a little confusing sometimes, but hopefully I'll do my best to make this as straightforward as possible, because once you see the pattern, it's not so bad. So what we're doing is we're defining this promise. We're saying we're defining what the resolved value is and what the rejected value is. Okay, that's the whole purpose of this callback. And so in this case, in the case of a flip coin, what we want to do is wait several seconds, output true or false, which will or we'll output heads or tails based on, we'll use like the math random function. Okay, so what we're going to do is we're going to say set timeout. And after, we'll do, I don't know, 1500 milliseconds, we're going to resolve this promise. So the question then is, okay, well, how do I resolve it? Do I return a value? Do I like, what do I do? So the promise constructor, this callback that we've provided as an argument, this function actually takes two arguments as well. And this is where they come from: resolve, reject. These guys are functions that the promise constructor gives us. So what we want to use this for is to say, at the end of 1500 seconds, resolve the promise. So to do that, we need to get what our value is that we want to resolve. So in this case, it's going to be the string either heads or tails. So we'll just say const result is equal to, and then we'll just say math.random is less than 0.5. So that will give us a, so if it's true, we'll say heads. If not, we'll say tails. Okay, so we're just going to generate a random number between 0 and 1. If it happens to be less than 0.5, it'll be heads and tails. This gives us a pretty reasonably close 50% chance. Okay, and then what we'll do is we'll simply say resolve with the result. Now, if there was some error, we would then want to reject it, but we're not going to worry about that right now. We're just going to worry about this resolve function for right now.
So
Okay.
you put whatever data you want to pass to the resolve, you just put it in the resolve function.
Correct. Yep.
It doesn't matter what you call it as far as naming goes.
Nope, has nothing. Nope. It's just this value is scoped just like any other variable. There's nothing special about this.
Could you have also gotten the same result by returning result? if you say return result instead of resolve result, is that the same effect, or is that?
No, it won't. Returning something in this callback is not going to do anything. If I put whatever I put here, that just means that this callback function inside of the set timeout is going to return some value, and set timeout's going to be, oh, whoop-de-doo, I don't care about that. And then the promise has no idea about what you're returning from this callback. So that's why it's important to use the resolve function, because returning here and returning here isn't really going to do anything. And if you look at the type signature for what the promise constructor is, notice how it's saying this callback that I've provided, this resolve callback, or sorry, the function that takes the resolve and the redirect, notice how it's saying it's intended to return void. So if I return, so it doesn't matter what I return here, it doesn't care. It doesn't worry about that value. It cares what this value is in the resolve function. Does that make sense?
Absolutely. Thank you.
Okay, so what we'll do now is run this code really quick, and then we're gonna play around with some tests in just a second as we kind of get better at this. All right, so we know that this result is going to be the resolved value from our promise, which is either going to be heads or tails. We don't know what it is yet, so what we'll do, I'm just gonna, this will be just silly, but there. Actually, I'm gonna put this. There you go. All right, so now what we'll do is we'll say, it came down as all right, let's run it. Oh, forgot about all this crap that I had up here. Boom. And if I call this again, hey, that time was tails. And tails. And tails. And tail. Oh, wow. And heads. Okay, you guys get the idea. All right, does that make sense?
Yeah.
So now that you know that flip coin is just an object, it shouldn't be much of a surprise that you can just pass these guys around, just like any other object or array or number or anything. You can save them as variables and you can return them from functions. You can pass them in as arguments to functions. Like they're just objects that just encapsulate some cool functionality. So one of the most, I think, what new devs have the hardest time with when they're first doing promises is they have a really hard time understanding that this is really not that special of a thing. It's just an object. So I want to emphasize that it's just an object. Now, this is useful because we can pass it around. And one thing that you should know is .then functions, this .then method, on every promise, the result of a .then is, guess what? Another promise. Okay, so the return value of a promise, or sorry, the return value of a .then call is just a promise. Okay, so let's ignore this for a second. Okay, so if I were to do this, that means that this is going to be a promise. Okay, so that just means that this is another object that I can then call dot then again. Now the catch is that the resolved value, so if I were to do something like this, the question then is, okay, well, what's this then? Like if I can continue chaining these dot then calls, the question is, what is that value? Where does it come from? Anyone want to take a guess?
The resolve.
To resolve, but like if I'm chaining it.
Oh, is it the
So maybe-
return? Is it the return in the dot then?
Exactly, that's exactly what it is. So I could do this all day. And at each subsequent call, I'm going to put in callback functions because that's just what it takes as an argument. Okay. Oh, and then this one. Okay, so at every subsequent then call, the argument that gets passed into the callback is simply the return value of what was from the previous dot then callback. Okay, so in this case, I'm flipping the coin and then my result, and just to prove a point, I'm going to return the result. And here's my result. I'm going to return the result. And then take the results, and we'll return the results. And then we'll take this result, and now we will show the actual result. Just format it so it's a little easier to read. Okay, so let's see if it works. Boom, no different.
So what's the best pattern to get those values out of that kind of promise?
Like, what do you mean?
I feel like that, like, and maybe this is like a novice dev question, but okay, you want to pull the result into something else. You want to use that head or tails someplace else. I feel like what I did is you just create a new function that you pass that into to get it out of that whole kind of promise land.
Yeah, so you, just like any other function call, you have to be aware of scope. So there's no getting around the fact that this function here is scoped to this promise, or maybe that's not the best way to explain it, but this dot then call, the value, the result in this callback, you are essentially, you still only have access to it in that scope. And that's just you know, that's just the nature of things, right? That's just has to do with the way that function scoping works. So if you want to use this result, then you would have to do your stuff in the scope of the function where it's available. Now you can, of course, play around with that a little bit. You could do something like this, like let's call this we'll call this the
winner.
Yeah. So now in this function right here, I have access to the result, and I have access to the winner. So I can, of course, do stuff like that. But look what happens if I try to do this.
Yeah, and I think that's what happened to me.
Yes, this happens to everybody. Like you think that you're gonna see this this happen, but of course, all I get is undefined. And not only that, it happens before I even see this console log, and that just has to do with the fact that all this is asynchronous. It's none of this even happens until after it's been resolved after the timeout.
So if you had done a set timeout and console logged the winner after like 2 seconds, would that have remained in the scope?
Yes, and that is a terrible pattern, but yes.
And then the other thing from my question before, on line 17, 18, and 19, those are all implicit returns, right?
Yes.
So you're not resolving result.
Right. I could do this. It's identical to this.
What I'm just trying to get to is that could you have said resolve result and it would have been the same thing?
What do you mean?
On line 17, if you had said resolve result instead of return result, would that have?
No, because I don't have access to a resolve here. All I have access to in the scope of this callback is that guy. The resolve function is only living in the actual, this is basically, this lives in the promise when I first created it, but now it's alive. It's the instance is already out of the bag. There's no going back. I can't call that resolve function anymore. It's in this black box.
Okay.
All I have access to now is whatever the result value is.
Got it. Because you had said earlier the return value of a then is another promise. So I didn't know if that meant that you could resolve from within the then.
You could. I mean, you could create another promise if you wanted to. And, you could go as many levels down as you want. Theoretically, but yeah, you don't once the promise has been instantiated, you no longer have the ability to adjust or determine how this gets resolved. Like you just don't have access to that function anymore.
All right, thank you.
Yep. Okay,
So
so
Ben,
note it. Oh,
would you
go
say
ahead,
that the pattern then is to do, in this case where you send off for a promise and then you want to do stuff with the result, is the pattern to do it within the dot then, the scope of that dot then? Or
Yep.
Okay.
Yep. There's really no other way to do it in a easy to manage way. That's the price you pay for having this nice to use interface. Notice I was able to do this, but this is terrible. Don't ever do this. Because you can't guarantee that that's going to happen exactly at 1500 milliseconds. You can't guarantee that that's always going to happen at exactly 2000 milliseconds. This is terrible. Don't ever do this. Don't try to save a value outside of a promise and then wait some arbitrarily long amount of time to grab it again. That's just terrible. But this at least I think illustrates the point though, that you do have access to this after the fact.
But you can do async await, right?
Yeah, so that's what I'm going to go over last is async await. Because async await is nothing new. It's literally just a cleaner, more concise way of doing this.
But with async await, you can do console log winner in line 26.
Yes, but it's not doing anything. There's nothing fundamentally different going on.
How
It's all the same.
how is no difference if we can do console log winner and here we cannot do console log winner?
Well, because in order to console log the winner, well, we'll do an example in a second.
Okay.
because that is a good point, and I'm glad you brought that up. So does anybody have any questions before we talk about async await?
How do you, I mean, are we gonna, you gonna show us the rejected?
Oh, yes, yes. Thank you. I'm glad you said that. I did actually want to talk about that. So, okay, so we have this arbitrary example where I'm flipping heads or tails. Either way, it is a result. Okay, so now what we're gonna do is we're gonna make this a little fancier, and we'll just allow the ability to have it reject. So instead of flipping a coin, let's do something where we do some sort of like validation. Okay, so some sort of like authorize. Okay, so this will be a new promise. Okay, we've got our function. Okay, now of course our arguments are resolve and reject. So, okay, so the way this is gonna work, this is totally arbitrary, but we're gonna pretend that we have some protected, we wanna log into this promise, which is a little silly, but I think also very helpful to see how this works. So we're gonna log into this promise, and the promise knows what the username and password is, but we'll assume that the person calling on the promise may or may not. Okay, so we're gonna have a saved username, which will just be I don't know, hello world. Super lame, I know. Okay, and then we'll have a saved password. Okay, and this will be goodbye, cruel world. Yeah, I like that. All right, so what we're gonna do is we'll use this set timeout again. One thing I want to just emphasize really quick is not all promises are necessarily temporal or time-based. It's just that it happens to be a common pattern. And they don't all use set timeout under the hood either. Okay, so the set timeout is going to, so the way this is going to work is in order to so-called, air quotes here, log into this promise, what we're going to do is we're going to assume that the person that wants to authorize themselves is going to put in a username and password, and then it will get validated. Okay, so for this to work, we're going to encapsulate this promise in a function that's going to take an attempt. Okay, so I'm just going to say, so we'll call it username attempt and password attempt. And it's going to give us a promise that will then allow us to check the innards of this function, this promise, against the attempt. Okay, so this is just a function that returns a promise based on those values. Okay, so what we'll do is we'll say if the username attempt is equal to saved username and password attempt is equal to saved password, then we'll simply resolve with a true, meaning you're authorized. Okay, else will reject it. It's false. It's a bad. It's a bad bad password. Okay, so it'll reject if these are not both true. Okay, and we'll do this set timeout after.
Shouldn't we tell the user which was wrong?
We could, but I don't want to overcomplicate this because it's a little irrelevant to the workings of the promise.
Okay.
But we'll just in a real scenario, yes, you would want to tell the user a little more information, but this is a little playground. So
We can in line 31, we can send like a message, right? Instead of true.
sure, yeah, we could do whatever we want. So, but what I'm going to do is I'm going to just use this value as this is going to true is going to represent you're authorized, false represent you're not. Okay. Okay, so if I want to authorize, I can now do my thing. So I'm going to say, so what we'll do is we'll say, okay, test and test. So obviously this is invalid. So actually, let's do invalid password, invalid username. So now I have a situation where I have I'm authorized. And now I can say, let's think of a message to write. Okay. Then I can do something like this. I can say, or sorry, now then has a counterpart, which is just catch. Okay, but it works the exact same way. Okay, so and in fact, you don't even necessarily need to have these values. For this example, it's a little unnecessary to do that, but oh well. So in this case, I'm just going to say, okay, authorization status unauthorized.
Meaning if you just run the resolve function, it'll return true.
Right. And yeah, so if I just do that and I just do that, then it just means that the value that gets provided to my promise, or sorry, my .then callback is just going to be undefined. There just won't be anything there.
Got it.
So like I should have done it this way just to begin with to prevent any confusion. Let's just do this. We'll keep it nice and simple. Welcome to the club. Otherwise, no soup for you. Okay. So, yeah, the case in point here is that you don't actually you don't have to have a value. In this case, we just know that if it passes, then this callback is going to get called. If it doesn't, then this one's going to get called. So let's run it. Let's see what happens. Oh, let me add one that will actually pass, which is hello world. Okay, let's try this again. Hey, okay, so the first one, no soup for you. Second one, welcome to the club. that make sense?
Yep.
Sweet. Okay, so the last thing to go over is Async Await. And Async Await is really great because it basically gives you, so it's not functionally different from this. And in fact, it's just, to use the cliche, it's just syntactic sugar on promises. It's purely a syntax addition. Under the hood, it works the same way. It implements promises. It's all the same. It just is Async Await just provides you with a way of writing promises in a very concise way, and it's pretty awesome. So we're going to rewrite this using Async Await. So let's try this again. So with our coin flip example,
Can we try something on line 31?
yeah, what's up?
One second, I'm trying to think. So, Now I was trying to introduce an error here in this promise, so we can go to the reject without using this if statement.
We can look at that after.
I'm sorry?
So we can look at that after.
Okay. Okay.
Yeah, because when you throw errors inside of a promise, it will it means that it'll get rejected. All right, so Async Await is a really cool way of writing promises. Although I highly recommend getting comfortable with writing promises using the traditional callback way, only because Async Await is so abstracted that sometimes it can be confusing. So Async Await, we're gonna write a function called coin flip. And it's a function. And it's going to give us heads or tails. Okay, so when we look at how we wrote it to begin with, is definitely a lot going on. Here, so there's no getting around. If you want to create your own promise, you still have to use the promise constructor. Like there's no way around that that I know of. Like that's how you're going to do it no matter what. So regardless of whether you're using async or await, you still have to, if you're going to create your own promise, you got to do it that way. There's just no way around it. However, if we want to process the result in a different way, what we can do is we can do something like this. So whereas before we were saying, flip coin, then do this, then do this, then do that, etc. What we're going to do this time is we're going to define this function, which is an asynchronous function. And you use that with the async flag. And if you want to do it using a traditional function syntax, you can also do this. I think you can. like that. Okay, so there's the kind of the two ways to do it. Usually I'm a fan of the E6 way, unless I need to use this for some reason.
Thank you. The syntax before hurt my eyes.
All right, so handle result. So when you define a function with this async keyword, all you're doing is writing a function that returns a promise. Okay, so the moment you do this, that means that no matter, even if I don't do anything in this function, even if this function block is totally empty, that means that my handle result function gives me a promise. And you can see that just based on the type signature that VS Code is giving me when I hover over it. Okay, so that means that I can do this. So that's the first thing to know about async await, is that when you define a function with an async keyword, you are defining a function which returns a promise. So even if you were to say return hello, that means you're not actually returning the string hello. So, you know, x equals handle result. X would not be hello. It would be a promise that resolves with hello as its resolved value. Okay, does that make sense? That I know confused me at first when I was learning about async await.
So you wouldn't resolve the string hello, you return the string hello.
Correct. Well, you don't resolve anything unless you're defining a function. So this resolve function, that is unique to the promise constructor.
And just because async is syntactic sugar for a promise doesn't mean that it has resolve.
I'm not sure I understand what you mean.
Did you say that async await was syntactic sugar for promises?
Yes.
And that's what's going on. So what of promises goes into async await, if anything?
Okay, so all this does when you're defining so when I'm defining a function with this async flag, what's really going on when the JavaScript engine processes this, what it really does. So let's say I took that async flag away. Now this is just a normal function. But the moment I do that, what this gets processed as is a function that will take that return value and this is an oversimplification, but this is kind of what this function turns into. So you can think of it in your head as, okay, whatever that value is, that's going to be wrapped in a promise, or it's the resolved value of the promise that is being returned by this function.
So in other words, we need to use async only in the places where we're gonna use also to fetch an API or something like that.
Yes. So you want to use async whenever you know you're going to be dealing with promises in the body of that function. This essentially is the replacement for this.
Okay, so you lose reject.
No, you don't lose reject. There's still a reject. You can still get rejected. It's just that you can now you can write your function this way. So this is the most basic example where, you know, if I were to call this, I'd get my string. Okay, so there it is.
I never use async without await inside the function. Is that something that is used a lot?
It happens. It's not common. I just did it this way just so you can see what async does on its own.
It is cool because
Yep.
I didn't think about that. Yeah.
Right. Yeah. Yeah. So okay. So this is a oversimplification, or this is a trivial example. Let's deal with that coin flip now. So now what I'm going to be doing is we're going to put await in here. Okay. So await is a way of kind of saying dot then without actually saying dot then. Okay. So for example, I want to save the value. I want to get the result of my coin flip. So there you go. So my coin flip is up here. Oh, sorry. It's called flip coin, not coin flip. Okay. So notice, to me, this is just so much cleaner than this. And it's nice because now all of these values are available in the scope of this function, which is pretty great. It's pretty helpful. So now what I can do is I can return the result if I want to. I can also do okay, so that is a lot cleaner than that, in my opinion. But let's call it. Let's see what happens. Hey, awesome. Okay, there's one kind of thing you always want to watch out for when you're doing this is now we know that handle result is a promise, or sorry, we know that it's an async function, therefore it returns a promise. So that means that this does exist. Okay. Question is, if I were to run this right now,
Undefined.
yeah, why?
Because it's console logs, but return value that you're logging.
Yeah, I'm not returning anything from this function. I'm not returning anything from this asynchronous function. So there's no resolved value
I believe by
that
default,
exists.
if we don't return, it returns undefined.
Say what?
I believe by default, when we're inside a function, if we don't use return, it returns.
Exactly. Yes, and that's just so that's actually nothing special with promises. It's just the fact that this async keyword is simply saying, hey, whatever the return value, if there is one of the function, it's going to be wrapped in a promise instead. So even if it's undefined is a perfectly valid value. So if you return undefined from this function, well, then when you call a dot then on the promise, that's what you're going to be left with, an undefined value.
I just realized that I never use return in async await functions. Is that a usual pattern?
Yeah, I can. Oftentimes, if you need to, for example, put a bunch of asynchronous, if you need to like aggregate a bunch of asynchronous calls together, like for example, I don't know, you're making a call to your server from a bunch of different places and you need to like I don't know, run a report or something. Well, you can aggregate your data all in one call, meaning you can just await multiple calls like this, and then aggregate it together the way you want to, and then return it. And then you can have a separate handler.
Yeah, that makes a lot of sense.
Yeah, and then deal with your data with another here. And you've got your aggregated data here. Does that make sense?
Yeah. If we go back to the way it was before, yeah, so what happens in line 54 to line 55? How is possible that we can get here the result and before we couldn't? Like, I don't see what is, I believe there is a little different. It's not like pure, what is sugar syntax called? I believe there is a little extra happening here in this way because we can get the value.
Not really, because all that we're doing is we're just getting access to this value in the scope of this function.
But there is like it's waiting. It feels like it's synchronous code because like I believe Danny asked before, the console log before we were getting undefined unless we added to set.
Right. And that's because under the hood, there's it's using what's called a generator, which is basically saying, don't execute the next line until this has been resolved. That's the whole purpose of await, is to be able to access values from an asynchronous call or an asynchronous process, and then still write code in a synchronous way. So like, while it feels like this is synchronous, it's not, because under the hood, this await is actually doing quite a bit. It's essentially doing this thing over here, and then, but then there's this other layer which the generator is handling before it executes the next line.
So that generators, what is not happening before in the callbacks?
It wasn't happening in the callbacks, no.
So there is something extra that is happening in Async Await.
Yes, but they're still promise based. There's nothing like there. It's not like it's a special kind of promise or anything.
Okay.
Like like it's not like you can't mimic this same thing doing the callbacks right here. Like I could just as easily write a function called handle result callback with the function that will say, okay, let result, and then we could do like it would just take a lot more code to make this work properly. We could say, okay, resolve, reject, do all this stuff. And we can then be like, okay, let our result equal this, and then we'll say, what would it be? Coin, flip coin. So now we're calling a promise inside of this promise, and we're saying, okay, result, and then we're gonna say, let's actually call this something else.
Response?
It's not really a response. Let's just do, actually, I'll call this result, and then I'll just do this with a little r. So then we can say, okay, result equals r. Or actually, even that's unnecessary. We can just say, okay, take this r, and then resolve r. we can say, okay, here's our promise. We're gonna create a new promise. We're gonna flip the coin, and then with the R, we'll take that result and then we can we have access to it. Let me think. I think I just confused myself. It happens a lot. Let's see here. We would say take a R, resolve it. And then we would actually, you know what, like basically we'd have to like aggregate it. We'd have to do all this fancy aggregating to get access to this value in the scope of this
So-
function.
We're trying to console log the result using callbacks. Is that what we're trying to do?
Well, that wouldn't be hard because I could just say turn coin. I keep calling it coin flip coin. It's flip coin. And then I can just do result and then just say console log result. Like it's essentially what's happening is like I can't escape the fact that I need to be in the scope of the callback for this value. So this isn't really different than this because in order to have access to this, I still have to be in the scope of where this promise gets resolved. So that happens to be here, whereas this is here.
Oh, that was my question. So I cannot declare a variable outside and use the result?
Not in a very easy way, no.
I mean, like in line 52 to declare a new variable and then to,
Well, I could. I should call that let. I mean, there's nothing stopping me from
then in line
like
50,
saying x equals result.
yeah,
But the
outside.
problem is that I still have that same issue where unless I'm in the scope of this function, I'm going to have a hard time pinning down that value. Do you see why?
I
Like
thought,
I can't just do this. That's not going to work.
can we check it? The undefined?
Yeah, it's going to be undefined.
I see.
Yeah, so there's not like I said, there's nothing fundamentally different going on between this and this.
That's very good.
Yeah, because all this is doing, all this function is this, it just gets wrapped up in a promise in a fancy way. And it just makes it easier to write multiple promises inside here. I could like, you know, have another one here. I could have like what I could do is I could have like a bunch of coin flips here. And in fact, this will be a good this. Okay, so now what I'm going to do, I'm going to write a function. So that's going to return this promise. This way I'm just going to be able to reuse this flip coin. So what I can do now is suppose I'm going to do record results. Okay. And my results are going to be based on flipping X amount of coins. Okay, so we'll say X is the number of coins I'm going to flip. And what we'll do So this is something that's really cool with Async Await, is I could then just be like, X plus, and we'll have our output, or we'll call them results. I think this will work. And then we will simply await the flip coin result. And at the end, we'll return our results. So if I want to record results for, let's say, 10, see what happens. There we are.
So that return in line 19, it's happening when everything is resolved for sure inside that function.
Yep. So did you notice how that took a while?
Yeah,
Yeah, why do you think that took a while?
because this is
A timeout.
Yeah. So what so I think this I didn't think we'd get to this to the multiple promises thing, but you guys are super smart, so we got there. So there's something really interesting happening here. Now, it seems like we would expect maybe one of three scenarios to happen. One is that we see these results get spit out every 1500 seconds. Another, I guess, option is expecting it to show only after X times 1500 milliseconds, which is what happened, of course. Or maybe like something in between where they're all happening all at once and then they all get resolved at once. And so you would expect it to either take 1500 seconds total for all the results to record, or in this case, 15 seconds, 1500 times 10, because it has to wait for every single timeout to resolve. But because it's single threaded, they all have to wait their turn. And that's what happens, is that we have to sit there and wait for a while before it happens.
so we're waiting 15 seconds.
Mm-hmm.
Yeah, I didn't expect that. I thought we were gonna wait 1.5 seconds.
Yeah, like I think our intuition tells us that it should only be 1500 seconds. Like it feels like they should all be happening like simultaneously, right? But they're not. They are not happening simultaneously.
Yeah, because they're chained promises. They're not run asynchronously. They're run chained.
Yep.
I felt like in the for loop, every time we were calling flip coin, that is synchronous code results that push. But the await flip coin is asynchronous. So I was expecting that flip coin is gonna be on the queue like in no time, but all those things in the queue are happening in 1.5 seconds.
Mm-hmm.
And then when we return the results, that's just going to happen in 1.5 seconds, but that didn't happen.
Yep. Yeah, because what this await is doing is it's saying,
saying dot
it's
then.
it's essentially saying, hey, flip the coin, which means wait 1500 seconds and then give me the result. So you can kind of think of this as saying, you know, wait 1500 seconds, plop it in the bucket,
and then wait another 1500
and
seconds.
then goes to the next one.
Because
Wait
it's
another 15.
because it's
Yep.
basically saying dot then flip coin, dot then flip coin,
Exactly.
dot then flip coin.
Exactly. And so then, because this function is a promise, it's not going to get to this point here until after all of these awaits are done. And so therefore, I'm sitting here and I'm waiting forever before I see them. So that gives you some insight into kind of what's happening.
Could you do an async results dot push?
What do you mean?
I'm not even sure if that would work. Never mind. Because I was thinking if you had on line 17 async results dot push, but then you would get nothing in the results because it would end up being undefined.
Let's see. What happens if we were to instead of waiting for each one of these, let's see what happens if we were to push the promise itself into this array.
It should be empty, I would expect.
Well, it won't be empty. We know that this returns a promise. So you'll have is an array of promises. Because remember, a promise is just an object. There's nothing fancy about a promise.
Right. So it'd be 10 not heads or tails.
It would be 10 promises in a pending state. And so that allows us to maybe ask ourselves, okay, well, suppose I do something like this. So if I know that my results are, well, they're not even really results now. These are flips. Okay, they're pending flips. So let's take our pending flips and map through them. I should have done a control F. Anyways, we can now say, okay, take our flip. Or I guess we don't really need to, I don't really care about whether I'm mapping or not. Okay, so for each flip, we're now going to do this. We're going to say, okay, take our result, console log result. Okay, is this going to be any different?
We'd hope that this would be about 1.5 seconds.
Total?
Yeah, because you're not waiting for the next to execute the next one. So it should be 1.5 seconds with some variance of however long it takes to call the next promise.
Oh, sorry. So you're saying it'll take 1.5 seconds per flip, and we'll just see them come out one at a time? Or do you mean like we're going to see them all at once in a 1.5 second?
I think you're going to wait 1.5 seconds, and they're all going to kind of chain out like in the next like milliseconds.
Okay. All right. Place your bets, everybody. Oh God.
Bet error.
If you had exception.
Oh, it's because I called them FIPS. It's like, psych, didn't expect that, did you? And you're right.
Yes.
Winner, winner.
Yep.
So it's almost like multi-threading.
Almost, but not really.
Yeah.
Actually, no, it's not almost because it's not multi-threading at all.
Yeah, for real. It feels like multi-threading.
It feels like it. Yes, it does. Because what's really happening is just that all of these functions are getting added to the event loop at almost the same time.
What about if we do, instead of the await, I mean, if we go back to the first implementation where it took 15 seconds,
Mhm.
and then yeah. Yeah, so instead of have the await there,
Mhm.
we move the await from there, and we have the await in the return await results.
Well, that's not going to work because results aren't a promise.
Okay, so you have to be in a promise.
Yeah, I mean, let me think. Yeah, so if we hover over that, await has no effect on the type of this expression. That's because results is just an array.
But results is an array of promises.
It's an array of promises, yes, but it's still just an array.
Okay, so
Because again, there's nothing fancy about a promise. It's just an object. So when you have an array of promises, you really just have an array of promises, or you just have an array of objects.
Mhm.
So you could do this. You could say like results dot map, and then for each result, you could await the result. Let's see what that does. Okay, what do they do? The argument list. What?
what's the error? Sorry, syntax error, map, await, res. Shouldn't be a call, res, and parentheses.
Should that be in brackets? The await.
I think so. Like that. Oh. I think that's why. No. Expected. Huh. That's interesting. Why would that not work? Oh, duh, I know why, because this is not it. That's not async. Okay, duh. Yeah, so
Okay, that makes
you
sense.
can only use await if you're going to use an await in the block of a function. It's that function block has to be an async function.
That makes sense.
Yeah. So there you go. Now we have kind of an interesting situation because let's look at what just happened. That is probably not what you expected. So, or maybe it was. Was it what you expected?
Yeah, it's getting there.
So the problem with this is that we're saying, okay, well, we're returning this array, right? Because map is just an array, or dot map just returns an array. So we're saying, okay, return this array that contains the contains the resolved value of this asynchronous callback.
Can we call res await res parentheses or no?
No, because it's just a promise. We're calling the flip coin function here, which just gives us this promise. There's nothing to call. Promises don't have call signatures.
Okay, I see.
Yeah. So this is actually, this async right here is actually misleading because it's not even necessary for this particular situation. Because now what we've done is basically moved it all down here. And so then if we wanted to actually see something, we'd actually have to do something like, because now that we know that this array is, well, actually, sorry, this does break it a little bit because now we can't call dot then on the return value of that function. All that does is give us a dot then ability. So then we could say, okay, take the results, and then instead of console logging them, we could, well, trying to think. Yeah, we'd have to, let's do this. So log. We'd have to say, okay, results dot for each. Here's our, now the thing is that these aren't actually results, they're promises still, right? Because anytime you're awaiting this callback function, yes, it's returning the awaited value of that promise, but this callback returns a promise itself. So therefore, if we're going to do something, these are actually promises. So we actually have to say promise dot then, and then here's our result. And now we should be able to console log the results for each one. And there we go.
And that took 1.5 seconds.
And it only took 1.5 seconds.
It feels like multi-threading.
It feels like it. But you shouldn't always listen to how you feel.
I mean, this is not even concurrent.
No, not even at all.
This is not even in parallel because. Just
So that was pretty much the same thing as you had before, just different.
Yeah, yeah.
Yeah, it was more or less the same.
It's instead of chaining the thens, it's saying go ahead and do this promise and move on with your life. And then go ahead and do the next promise and move on with your life. And then it says, okay, let's get them all back, but now let's resolve the promises that we just
exactly
fired off.
Exactly. Yeah. So we're not doing it in bulk. We're doing them piecemeal.
So it's just a bunch of promises that you fired off 10 of them in a row, and then you got back the 10 of them.
Yes, I got 10 promises in a bucket, and now I'm going through each one and resolving each one. Or I'm
saying promise and then wait for that promise, then do the promise again and then wait.
Correct.
But the first that then we use it in line 24 is because the async.
That's because of this.
Okay.
In that function, yeah. Without that, then this just becomes a function which returns an array. Whereas before, now I have a function which returns a promise which resolves an array. And you can see that with the type signature here.
So if you get rid of the async on 14.
Yep, this is going to break completely.
But can we just do can we remove one that then from the record results? Like, actually before that, can
we would just have to say map.
Okay.
Or for each or something, because now that that's just an array. Oh, right, because result is now. Oh, right. And now this is just a. This is now just simplified to this. Oh, shit, I got rid of the. You still have to say dot then.
Right, because each of those items in the array are promises. You still have to resolve.
Correct. Correct. Yeah, you still, if you want to access the value inside of the promise, you still have to call dot then on it at some point.
We need to say console log R at the end.
Oh, oops. Thank you.
Okay. Gotcha. This is mind blowing, but makes sense.
That's pretty
Yeah.
cool.
Yeah.
Well, thank you, Ben. I gotta get
Mhm.
going.
Yeah, no problem. Yeah, I hope that made sense.
I believe
We
this.
went into a kind of a rabbit hole there. It's pretty cool though.
I believe this is between quotes the best implementation of if you want to do don't wait 15 seconds, right? That would be like
Yeah, yeah. You wouldn't want to wait because even by making that number, even 20 makes it excruciatingly long with the other way.
I didn't know that's how exactly it works, but that's cool to know.
Mhm. Cool, cool.
Well, thanks again, Ben. Good.
Yep, yep.
work,
You're welcome, Danny. I'll see you guys next week.
Yeah, see you next week. A little
Cool,
better
cool.
turnout today, which was good to see.
Yeah. I mean, with the holidays and the insurrections and all, it's a crazy couple of weeks. So glad to be back.
Cool.
Alrighty, well, we'll take it easy. Next week, the topic is, what is the topic next week?
I believe it was rejects. So
Oh yeah, it's regex.
Ooh, must needed.
is there a way?
Yeah. What?
Is there a way that we can switch the topics? The
A way to
webpack,
switch it?
the webpack to go first before rejects? Just because I need some type of webpack knowledge by Tuesday of next week.
Hit me up on Slack. I'll help you.
Okay, cool.
Yeah.
I appreciate.
Yeah. You said before Tuesday, you said next Tuesday or tomorrow?
No,
Wait, what's today? Yeah, today's Monday. Every day feels the same. Yeah, Giovanni, feel free to hit me up. I'll be happy to help you with some webpack stuff.
Thanks. Cool.
Yeah. Cool. Well,
Okay, have a good one.
have a good night.
Thanks,
Bye.
man.
Peace out.
What's the best day for you this week?
Let's do, is Wednesday okay? Like Wednesday afternoon?
What time is good for you?
Anytime after 3
All right.
Mountain State time.
Okay, I will send you a message at 3.
Okay, cool.
Cool. Thank you, Ben. I appreciate it.
Yep. Have a good one.